Well, it's been kind of a busy weekend for stereo equipment. It turns out that I finally completed my stereo speaker protector project. So this is something I started building a couple months ago when my collection of vintage Technics receivers from the 1980s was still down to 1 or 2, maybe 3 units. Anyway, this was created because the majority of the Technics receivers from this time frame, they use a Sanyo hybrid stereo power amplifier in a box that basically requires very little additional circuitry. Well, one of the circuits that is external to the unit, the amplifier hybrid, is a protection circuit. And rather than using a relay like most receivers do, so if something goes wrong, the speakers become electrically disconnected from the amplifier, Technics just decided that they would use an electronic circuit that is supposed to turn on a transistor when a current rise is detected. Well, it's a good theory, but it doesn't actually work. And the only 2 receivers I have that are exceptions to the rule are my SA-310 and the SA-560, both of which have an honest-to-goodness outboard protection relay that should work to save the day. But in the others, usually what happens is the protection circuit, I'm told, gets blown away, and your speaker can end up with a power supply rail on it, full throttle direct current, usually at least 45 volts worth, and that will melt a voice coil in no time. So what this thing does, this accepts input up top and passes through the output on the bottom, and ordinarily it does nothing until something goes wrong with the amplifier. If something should go wrong with the final transistors in the amplifier or the hybrid module, this thing, once it detects a DC voltage of past 1 volt, and I tested it, that's what this little battery is for, this thing will cut the connection between speakers and amplifier, and it latches. So even if the fault clears itself, there's no chance for your speakers to become reconnected to an amplifier that's become hazardous for them. Anyway, this thing was made out of a project box. It's got a fuse holder, a push-button switch. A lot of this stuff came from Radio Shack. I absolutely would not recommend this little push-button switch. It's a strange size for which I had a great deal of trouble finding a drill bit. The fuse holder came from eBay. The project box came from eBay. The power cord and its nice strain relief came from a scrapped TX stereo receiver that I decided wasn't worth fixing. And of course the speaker connector, something that I was surprised Radio Shack had, with a total of 8 positions on it. I was surprised they had it, but they did, and so it seemed like the cheapest place to buy it, which was kind of odd, but it was only like, I think, a $3 bill. Anyway, this thing has a transformer in it that energizes the circuit in here, which is a pretty simple circuit consisting of some transistors, capacitors, and relays, and when it detects a DC voltage flowing into it, it shuts things down to protect your speakers. So I will definitely be using this, and I may build more than one for use with my vintage Technics stereo receivers that don't have an effective speaker protection circuit in the case of amplifier failure. But you turn this thing on, and seconds later you'll hear a relay click to indicate that the circuit has been closed and the speakers are now connected to the amplifier. If the amplifier failed, you'd hear another relay click, but you'd be much more likely to notice the sudden silence when your music stops playing. So what's inside it? Well, I'll show you. Here's what makes the unit tick. There's a little Radio Shack center tap transformer for power. Power leads are over on the right-hand side of the board there. This is the actual protection circuit board right here. I thought about just building one of these myself, maybe using point-to-point wiring, because I have never tried to make a circuit board before in my life, although I'm told you can buy kits that let you do so on a laser printer. But then I got to looking on eBay and I discovered that there are sellers in Hong Kong that have these things by the dozen, and they're much cheaper and much less frustrating than trying to make one on my own. So I just went that route and bought that from a seller operating under the name of 8 Audio. They actually show their logo as a treble clef, but there's no way to type that on a computer keyboard, so they took the number 8. Anyway, you can see where the signal comes in from the top bunch of connectors. You can see where the signal goes out to the bottom bunch. This thing actually protects both the negative and positive leads and will trip on either one of them carrying a DC voltage. I have tested it. One of the taps from the transformer goes up to the switch with an LED light in it, and there's a resistor been soldered into place there, and heat shrink tubing covered, and then the other two connections serve to turn the power on and off. There's the fuse holder up there. It's kind of tight in here. This box probably could have been bigger and it probably would have worked better, but this seems to work fine nevertheless, and the important thing is that the circuit works, and that it definitely does. And although the transformer is not exactly silent, it's not loud enough that it's going to detract from the music, and it doesn't seem to be inducing a hum into the speakers, at least not from my tests so far. So that's the protection system for the speakers. Anyway, for all the wiring in here, all that wiring came from a scrapped PC power supply. You might have guessed, and you'd be absolutely right at this point, I don't let much, if anything, ever go to waste in any of my projects. So the old E-Machine's power supply may have been a piece of crap, but it provided enough different multicolored wires that I could have a different colored wire representing each major circuit path in this thing, just to help keep things a little bit straighter and to make it easier to service should it ever need that down the road when I've forgotten exactly how I built it and what pieces and wires went where. Less pleasing news, it seems I broke my Technics SA-310 receiver. This is the new computer drive one that's demonstrated in the video. I was listening to it almost all of yesterday afternoon and evening. Most of the afternoon I spent listening to my CDs, and then in the evening I listened to a radio program, and I noticed that when I started to turn the volume up, as a person would for a good song that's nice to listen to, I noticed that the output of the left channel started to get rather distorted, but that it would always straighten out when I brought the volume back down. Well, sometime during the radio program, the left channel died the rest of the way. I was really hoping it was a problem, but it turns out it most likely isn't. I think I ended up killing one of the channels in the hybrid STK-2038 Series 2 amplifier. Fortunately, it seems that a seller on eBay has some replacements, although they're generic, so I don't know what their quality is like. But I'm hoping that I can get this back on its feet, because when it did play, it sounded really good. I am very seriously considering the possibility of circuit modifications for this SA-310 receiver, because one thing in particular I have noticed, it runs frightfully, spectacularly hot when it's in operation, and I can't help but think that that has hastened the demise of the power amplifier module. Now, I've got to be fair. I mean, the module is 27 years old. It's as old as the rest of the receiver. Most of the date codes inside it point to an early 1983 date of manufacture. So I can't say that it didn't last a good long time, but the cooler you can keep any semiconductor device, the longer it's going to live and the happier it's going to be. So my idea will be, with the help of the service manual and things like that, to find a low voltage tap off the transformer, rectify it to DC by way of a diode if necessary, and then take a small fan and mount to the end of this heat sink to try and circulate some more air through here. I'm also going to go ahead, although I don't think it's strictly necessary to do so, I'm going to go ahead and replace these two filter capacitors in the unit, because they have been sitting right in the line of fire, so to speak, between the intense heat produced by the transformer and the heat produced by the power amplifier. So as much as I hate to modify a vintage piece of equipment, I think it's going to be all for the best in terms of reliability and things like that, because I want this unit to operate reliably, and I'm just not sure that it will, and I'd really rather not sit here and feed it power amplifier modules on a regular basis and or risk my speakers unnecessarily. Then there's the SA-560, which, as you might remember, generally worked well, but some of the front panel lights didn't work. Well, I've gotten that problem fixed. If you're going to work on yours, I would definitely strongly recommend that you get the service manual, because it tells you some very important things that you need to know to get the front panel off of the unit. And if you go in search of a service manual, I would definitely recommend, as nothing more than a satisfied customer, the products sold by Stout & Associates at StereoManuals.com. They're pretty reasonably priced and they're good quality. I also wouldn't recommend this unless you like getting knee-deep in little parts and cables and push-type fasteners and things like that. But suffice it to say that now all the front panel indicator lights work just exactly as they should. Only bad thing is this thing was periodically starting up without one speaker playing, and that pointed me to dirty contacts on the DC protection cutout relay. So I thought, no problem, I'll open the relay. I'll clean the terminals just like I did on my SA-310 receiver. If only it were that simple. I pronged the relay's coil, I broke loose a couple of turns of magnet wire, and I broke the relay. So now I've got to find a replacement. So for the meantime, this poor receiver is completely silent because there's no relay inside it. I found some people selling the original Panasonic relay, but as it turns out, they wanted $30 for a $4 at most relay? What a ripoff! So I bought a compatible relay with a 24-volt coil, and I may have to put it on its own separate little print board and circuit inside the unit. This thing also had a slightly bent cabinet, and while it's not perfect, it no longer pokes out at the edge like it used to, and it's no longer bowed in from having years' worth of heavy equipment sitting on the top of it. So this thing is just about perfect cosmetically once again, and as soon as I get that relay, I'm sure it will play beautifully.